What is the ratio of wavelengths of last line of a Balmer series and last line of a Lyman series? It's known that to find the ratio of wavelength of last line of Balmer series and the last line of Lyman series, we can use a formula of wavelength of a spectral line in hydrogen atom, which is derived from Rydberg formula, which is nothing but 1 over lambda is equal RH times 1 divided by N1 squared minus 1 divided by N2 squared, whereas RH is representing the value of Rydberg constant and lambda is representing the wavelength of an emitted light, whereas N1 and N2 is representing the principal quantum number of a corresponding energy level. And it's known that N2 is always greater than N1 also. So here the question is about last line of Palmer series and Lyman series. It's known that the last line of Palmer series corresponds to the transition from alpha to 2, or else we can say N2 is alpha and N1 will be equal to 2 in terms of Palmer transition. Similarly, we can write the last line transition of Lyman series as N2 is infinity to N1 as 1, or else we can say it's from infinity to 1 in terms of line. So the value of Balmer series can be written as 1 divided by lambda is equal RH times 1 divided by 2 square minus 1 divided by infinity square. When we are simplifying this, we will get the value of RH divided by 4. Similarly, the value of Lyman series can be calculated as 1 divided by lambda is equal RH times 1 divided by 1 square minus 1 divided by infinity square. When we are simplifying this, 1 over lambda will be equal to RH. So this is a value of 1 over lambda p. So when we are calculating lambda b, it will be equal to 4 divided by RH. Similarly, lambda L will be equal to 1 divided by RH. Here, the question is about the ratio. So lambda Balmer divided by lambda Lyman will be equal to 4 divided by RH divided by 1 over RH. When we are simplifying this, we will get the answer of 4. So here we can say the ratio of wavelength of last line of Balmer series and the last line of Lyman series will be equal to 4. And the correct answer here is option B.